Welcome to this video on the topic of networks. In this video, we're going to have a look at how we can go about discovering the longest path between two nodes within a connected network. The algorithm we're going to use is similar to the algorithm we use to discover all of the unique paths between two nodes within a connected network. Now, the longest path algorithm consists of 6 steps. The first step of which requires identifying the starting node, or the node that we're going to start from. The second step being that we assign the starting node a path weight of 0. In the third step, we're going to look at and see what nodes are connected to the node we're currently sitting at, from which we're going to compute all the prospective path weights. After we've calculated all of our prospective path weights, we're then going to start assigning them. Now, there's going to be multiple ways to visit different nodes. Consequently, we're always going to preference the path that's going to have the highest weight. Reason being is we're looking for the longest path. For step 5, we're going to go back to step 3 in the case that we haven't finished weighting all of our nodes in the network. Or in other words, if we don't know the path weight to each and every single node. Only once we've managed to find the path weights for every single node within the network do we move to step 6, in which case we go from our destination node and we backtrack through the network until we reach the start, during which we discover the longest path. Applying these rules to example A over here. In example A, we have a network and it consists of 5 nodes and 1, 2, 3, 4, 5, 6, 7 and 7 arcs. The starting node for this example is going to be node A. Consequently, I'm going to write a path weight of 0 to node A. Now, observing this, there are no other paths that are going to lead to A. As a result, I'm going to put a box around it just to symbolize that this has been finalized. Looking at the other nodes within the network, A is connected to node B and D. To get to B, it's going to ensure a cost of 4. To get to D, it's going to ensure a cost of 3. Now, I'm not going to finalize these yet because there are multiple ways we can still get to D. However, if we turn our attention to B, we're unable to travel to B in any other route. As a result, B is going to be finalized. Now, starting from the next finalized node, we have B, and I'm going to observe where we can travel to. We're permitted to travel to C, and it's going to be at a cost of 4 plus 2. So that will be 6. And we're able to travel to E. That will be at a cost of 4 plus 5. Thus resulting in a path weight of 9. Looking at C, there are no other nodes that are going to lead us to C. As a result, we're going to finalize that node. Now, working from C, we observe where we can move to. We're able to move to E, and that's going to come at a cost of 6 plus 4, which will result in 10. And D, we're able to move there at a cost of 6 plus 2, thus resulting in a value of 8. Consequently, this is the final path we can use to get to D. As a result, we're going to preference this longer path like so. Because this was the final path, D is now finalized. Now, the final path we're going to look at is where we can get to from D. Now, D is connected to E. Traveling to E via D is going to ensure a cost of 8 plus 7. Or in other words, it's going to cost 15 to get there. Consequently, this is the highest weighting we can do. And there are no further paths that will lead to E. As a result, E is finalized and we are therefore able to calculate the pathway to get to E. Backtracking, we went from, to get to E we went via D, to get to D we went via C, to get to C we went via B, and to get to A we went via, or to get to B we went via A. Thus, the longest path connecting A and E So a nice simple example. Now, the shortcomings of this particular example here is that the algorithm we use and the way in which we've denoted it is such that when we're looking at it, we're always going to find that if there are more nodes, it's going to be confusing to trace our way back. So in example B, we're traveling from A to I. Calculating the longest path from A to I, we're going to first identify our starting node, in which case it's going to be A. because A is our starting node, I assign it a value of 0. Secondly, because A, it's unreachable by any other node, we say it's finalized, denoting it with a box, like so. Looking outwards from A, we're able to reach nodes B and nodes D. We reach node B at a cost of 4. Reaching node D, we reach at a cost of 7. We're unable to reach any other node other than going through these nodes here, so we're going to finalize it. Alright, from the perspective of node D, we're able to reach node G. This will come at a cost of 7 plus 5. That will result in a value of 12. And we've come from D. We're unable to reach G through any other node, so we can finalize it. Furthermore, going over to B, we're able to reach C from B using a cost of 4 plus 2. So therefore a net cost of 6, and we've come from B. Looking across to E, there's two ways in which we can get to E. The first route is via B. It's going to come at a cost of 4 plus 4, which will be 8. And we're moving from B. Similarly, we're able to reach E through D, and that's going to come at a cost of 7 plus 2. So that will be a net cost of 9D. Because we have two path weights we can choose, we're always going to choose the heaviest of them, so 9D is the winner in this case. Moving down to H, we're able to reach H through two methods. We can either go through E, which will be 9 plus 8, or we can go through G, which will be 12 plus 1. That will be 13. And the other one is going to be 17. Through the route going through 17, it's going to be through E. Whereas the route that costs 12 or costs 13 is going to be through G. We're going to preference the route through E, as that's the heaviest of them. Node H is now finalized. Going across to F, we're able to reach F through two ways. We're able to go through C at a cost of 6 plus 4, and we're able to go through E at a cost of 9 plus 3. 6 plus 4 is 10, and that's through C. And then the larger of the two, we have 12, and that's through E. Route F is, or path F is now finalized. Going down to I, we can reach I through two ways. We can go through F at a cost of 12 plus 5, which will give us a value of 17. Or we can go through H at a value of 17 plus 6. So naturally we pick the heaviest of the weightings. And therefore the route to I is now finalized, as we have exhausted all different paths we can take. Now tracking backwards, you simply look at the numbers that are represented. So in this case we've got H here. All I need to do is move it back to H. From H we go to E. From E we're going to go across to D. And from D we go up to A. And thus we have been able to compute, or we've been able to discover the longest path within this network. So in summary, what we set out to do in this particular video was to learn how we can find the longest path between two nodes within a connected network, and we did it using these 6 steps demonstrated down here and here.